Coming up on this episode.
Limestone. You can see this is a nice thick block of limestone, but you can see beautifully how this shrimp is preserved. Now, shrimp are used as bait. Hi, welcome to Evidence for Faith. It's your host, Michael Lane. So glad you're joining me today as we talk about another creation clue. This one is, what's the deal with fossils? Yeah, what's the deal with fossils? Because I'll tell you, I was taught something when I was in elementary school that bothered me for years. And we're going to get into this because it deals with fossils. But before we begin with that, let me tell you a little story of what just recently happened, not very long ago. I was speaking at a church, and after I got done speaking, people were coming up and we got in conversations and stuff. And one man came up, now this is a Christian fellow, one of the leaders of the church, came up to me and he says, I agree with every single thing you said except one thing. I said, what's that? And he says, I cannot accept that the earth is young. I believe that the earth has to be billions of years old. So I asked him, what was the roadblock that he had in believing literally what the Bible was saying on this? And he responded to me, I'll tell you what the roadblock is. He says fossils. Fossils prove that the earth is billions of years old. And he said, since they're found all over the earth, all over the world, he says that proves that the earth is really old. Now, I'll tell you, to be honest, that's not the first time I've ever been having a conversation, or this has been brought up to me about fossils and the age of the earth being old, et cetera, et cetera. That is something that commonly comes up when I go around speaking at places. And they believe that the earth is billions of years old because of fossils. Well, I know many Christians that accept that. And to say that the earth is billions of years old and that fossils are irrefutable evidence that the earth is billions of years old, I don't think that's accurate whatsoever. Because of what I have found out, not just being taught, but just logic and being able to see things myself, dealing with animals and stuff and finding fossils. In my area, even in my driveway, we had limestone rock that was brought in. And I remember as a little kid in elementary school sorting through certain fossils, little pieces of sedimentary rock, limestone and stuff, and seeing little seashells and stuff that were fossilized in it. So like I say, it's not the first time I ever heard this, and it has come up quite a bit throughout the years. So I want to take a little bit of time and let's explore this whole problem that we have with fossils. Do they really prove that the earth is really old? Now, what is usually taught in school is that fossils, and I think I was in 5th grade when I got my first lesson on this, of how fossils are formed. I still seem to remember my 5th grade textbook on this in science talking about this, that how fossils form. Now, it's taught in most schools, most public schools, even some Christian schools will teach this, that fossils are millions of years old and show life from millions of years ago, et cetera, et cetera, et cetera. And not necessarily thousands, but millions. Well, where did we come up with the idea of how fossils form? You find it in every textbook, as I said. Oxford University, though, has on its website a description talking about how fossils form. It's used, the same basic formula is used in many, many science books. And it's a 5-step system that they describe. The first step in this is, number one, the animal, or organism, whatever it is, the animal dies, and the skeleton, or the remains of that animal, then settle on the sea floor. And as it settles on the sea floor, it gets buried in wet sediment. Now that's the first step in forming a fossil. The animal dies, gets buried as it lays on the sea floor, and gets buried as time goes on. And then we come to step 2. Step 2, the sediment surrounding, and as it keeps descending and falling on stuff, it sets around the thing and covers the specimen itself, and the surrounding skeleton, this organism of whatever it was, begins to thicken and it begins to turn into stone. So as more layers are added throughout this, they illustrate in the textbook, as more layers keep coming down, that causes pressure and weight, and what's happening is the animal is being surrounded totally by this rock, this sediment. Now the third step is really important, because the skeleton then has to dissolve. The organic material has dissolved away already, but the skeleton is the last part that goes. The skeleton is dissolved and it forms a cast or a mold, like you would pour plaster into a mold, forms a mold. See, it's been buried now in the sediment. It has disintegrated over time because of groundwater and other things. This has left a skeleton, and the skeleton itself gets dissolved. But the original shape of the organism remains. So that's the third step. Now, the fourth step in this is very important also. Mineral crystals get inside this mold or this cast, and they form, just like you would pour plaster inside, it forms the object. So water-rich minerals enter into the cavity, fill up the cavity, and then the minerals develop this cast. It's the same shape of what the organism was. That's very important. You get the shape of the organism, but none of the original internal organs are there. It's just going to be the shape of the organism. Then we come to the fifth and final step. The fossil now that has formed there gets moved up to the Earth's surface. And as time has gone on, wind erosion, water erosion, rain, etc., starts to remove the layers of sediment until finally we get just the fossil itself exposed. Now that's what is taught in schools. It's just the basic science behind the theory of how this forms. It's found in every single biology book or geology book in particular. They teach this. And I was taught this, like I said, I think it was in 5th grade. I actually went home after learning this about how fossils are all over the earth. I remember digging holes all through my backyard with my best friend. My parents were thrilled when they got home after that. But anyway, I took what my science teacher was saying, what it said in the textbook, as just the truth, without questioning anything about it. Now there is where sometimes we make our mistakes. It's because science is known to constantly have to change as more information becomes available. And sometimes what we believe today in science, which is what is taken as truth today, centuries ago was not how it was, that science taught things incorrectly many, many years ago, and as many times science sort of takes a while to catch up to the truth. We have a whole series on this. If you want to do the Science in the Bible series that we have on our website, you can check into that. But you see, there was something wrong with this scenario that Oxford lists, and it's found in all these textbooks and science classes that they teach us. There was something wrong with it. I couldn't put my finger on it at first. Matter of fact, I just didn't see a problem with it. But as I grew older, getting into high school and stuff, I started to see something not quite right. I think, to be honest, I think my first experience in thinking about how fossils, that they couldn't form that way, all of them could not form that way, was when I went to visit my brother in the Bahamas. And on my first visit there, we went on a Sunday and we went to the southwest side of our island of New Providence, where we live. And we went over there and we just were going through tide pools. We're about knee deep in this crystal clear water. And I'm seeing, for my first time in the ocean, I'm seeing all sorts of amazing creatures. And these creatures, I was picking them up and looking at them and stuff like this. And being a high school student, like a curious person, I was often killing the animals and organisms as I was studying them. And I would pick some up, and I would, like in some cases, I broke some things, broke the animal apart or whatever. But I was holding something. This is where it got interesting to me, and where I started to get a new revelation about this. I killed an animal. Intentionally, yes, but I wanted to see the inside of it. I broke it open, and after I got done examining it, I just dropped it in the ocean. I'm about knee deep in the water, and it fell down in this crystal clear water. When it hit the bottom, hit the sand right below below me here, right in front of me, I was absolutely amazed at all these creatures zooming in out of anywhere. I remember a crab coming up out of the sand that I didn't even know was there because it was like invisible. It was hiding in the sand. It came over. Fish came over, and other things started coming over and just devouring this creature until, after a while, there was nothing left. It didn't form a fossil. The animal died and was consumed very, very quickly. That was really interesting to me. Later on that week, I went out with my brother to go fishing. And we didn't have poles, we just used lines with hooks and stuff. But I remember throwing my line out and catching a fish, and it swallowed the whole hook. If you've ever fished, and you know sometimes the fish is notorious, it'll swallow the hook down to the belly and into its stomach and stuff. This was the case. And I had nothing with me to try to get it out, and I hate to say it, but I yanked and pulled. I tried my best not to injure the fish. I killed the fish as I was pulling out the hook. And the fish was too small anyway to keep or anything. I just remember as we're standing there on the edge of this little dock area, and I remember just throwing it back out in the ocean. And I noticed something that I never, even though I'd fished many times, I'd never noticed this before. The fish didn't fall down to the bottom, like it says in these textbooks that the animal dies and falls to the bottom. It didn't fall to the bottom. It floated on the surface. And as I continued fishing, I kept my eye on this dead fish just floating there, and it's oozing out chemicals and stuff and scents into the water. And before long, all of a sudden there was a huge splash right where that fish was floating around. It was gone. Some other bigger fish came along and swallowed it. It was its meal. That fish did not fall to the bottom like we just read about, or I just read to you about the different stages of how you make a fossil. It didn't get there. It was devoured by something else. A predator or a scavenger took it. So these kind of things started to make me think that, wait a minute, I thought fish died, they go down the bottom and it would form a fossil. It didn't do that. Now, the two examples I just gave you explain that animals don't always turn into fossils just because they're dead and they lay on the bottom. Because if they lay on the bottom, like in the first example, crabs, lobsters, shrimp, gastropods, polychaete worms, all sorts of scavenging fish and stuff come over and they devour the thing and they eat every trace of it. And then what traces are left there, fungi and bacteria will break it down until there's nothing that remains. And matter of fact, I was reading in an article just recently, an older article, but it was about James Cameron, the director of the movie Titanic. It was on television the other night, and I sort of pulled this up to read about the making of this. And he visited the Titanic wreck. He actually went down 33 times to the Titanic. And I pulled up an article out of the New York Times back in 2012, where James Cameron was being interviewed, and he was asked by a journalist, have you ever found any remains of any humans? Because a lot of people died, as we know, on the Titanic and when it went down. And this is what he said, and I'm going to quote this. We've seen clothing, we've seen pairs of shoes, which would strongly suggest there was a body there at one point. But we have never seen any human remains, unquote. Well, one of the main reasons they haven't found human remains is that scavengers devoured it. Thus, they did not form fossils. And this has been true on many shipwrecks that they have found from antiquity. They just don't find, a lot of times, particularly in deep water, because of the chemistry of the water will dissolve under super depths and pressure, will dissolve calcium products like bone and things. So this just doesn't happen in the marine world. It seems like everything I'm talking about is the ocean. This also happens on land. For example, let me give you another one. Years ago, back around 1999, I moved to the North Woods of Wisconsin to work at a Christian camp. Everybody, if you live in the North Woods, you have to go deer hunting. I've never hunted deer before. I'm more of I don't really like going out and killing deer. I wasn't really fond of venison that much, particularly in the North Woods. I'd tasted it up there before, but I really wasn't crazy over it. But I went out deer hunting, and I was using a rifle that only had one single shot to it. And a deer came up. It was about 200 yards away. I shot. The deer went down. And I'm feeling victorious. I go down there to go get my deer, carrying my rifle, which was now empty. And as I walked down about halfway, I noticed the deer struggling to get up, managed to get up. I stood there just watching this. And the deer managed to get up and started wobbling, trying to run in the most bizarre way because it was severely injured. It was dying. And so I pulled out my knife and I thought, I'm going to chase this thing and just stab it and kill it. Well, this was just before dark. This was right at the end of the time you could still legally shoot. And I'm chasing this thing through the dense forest, and then I realized I'm not going to be able to get this thing. and my rifle's empty. I thought it's not going to go very far. I put my knife back in the sheath. I run back up and to get another bullet, which I did. I retrieved, went back, and now I couldn't find the deer. And darkness was descending, and I'm looking around. I went back to where I thought I shot the deer, about 200 yards away, and I'm looking all around. I couldn't find it. As I was heading over, I saw two friends of mine who were hunting, heading back to the cars. I said, "Can you guys help me?" They came over. We looked all over. Because there was no snow, and here's the key, there was no snow on the ground. It was, at this time, we were hunting, and it was just plants everywhere. You couldn't find a blood trail very easily. And now the dark has descended on us. We couldn't find it. And so we went back, and I thought, well, it's got to be just laying there someplace. It's below freezing. I'll get it the next morning. So I went out early the next morning with a friend, and we scoured around that area there for a little bit, trying to find the deer, and we couldn't find it. Never did find it during that season like that. Winter came, we started getting snow. Now we know it's going to get covered, et cetera, et cetera. It went on. Well, when spring came, I went back out looking for that deer, and I found it. It was about 50 yards further down from where I was. So I guess my shot was a little bit longer than I thought. I did not have a scope, and the deer was more like about 250 yards when I shot the thing. But I did find the deer. It hadn't traveled very far, and I just lost it in the dark and stuff. But now I noticed when I found the deer, this dead deer, in the forest, it was not intact. As a matter of fact, it was scavenged. It was in different sections all around in an area. Legs pulled apart, ribs broken and chewed off, and all sorts of things. It was a mess. And so instead of doing anything, I sat and I studied that. And I kept returning about every week, watching and seeing how this thing was changing over the next year as this went on. And eventually, almost all traces outside of the skull, almost all traces of the deer were gone in a matter of a couple of months. My whole point, I'm not talking about is how bad of a shot I was. The point I'm trying to make is it didn't form a fossil. It did not make a fossil. Even though it was killed on land, it does not make a fossil that way. And the reason is because scavengers took the thing and ate it up and scattered it all over the place. Now, scavengers and decomposers, which came along afterwards then, in a short time remove almost all traces of the dead animal. Now that we have that, let's take a look at some fossils. And let's see what they can tell us about the age of the Earth. The first one I want to look at is a fossil of a fish. So we're back into the aquatic environment. A fossil of a fish. You can see this is not very large. And this fish here, you can see it's perfectly aligned. You can see quite a bit of detail around this. Now, according to Oxford, I've already explained to you how the different 5 parts form to get this thing. And this fossil here then is embedded. Here you can see the other side. There's nothing there. It just looks like rock. You turn it over, it's been split, and you can see this beautiful fossil of this thing. Now, this specimen and specimens like this are found on all continents. You can find fossils of fish all over the place. But do you remember what I told you about my first experience? About how things devoured it, and then the story about the fish that I killed, it didn't sink to the bottom, it was eaten. How did this fish get to the bottom to form this fossil? And I started wondering about this, and that's what made me start thinking, how did this fish make it all the way to the bottom? And you can see pictures of just a whole lot of fish all over in an area that are all perfectly preserved in the fossil form. How did they do this with nothing coming along? No scavengers, no worms, no bacteria, anything breaking down the animal or other fish eating. And so how did this happen? Because if you look at this, you can see distinct details. You can even see the vertebral column going along the edge here inside this fish. I mean, it's beautiful. You see how the fins are extended. The caudal fin, the dorsal fin, the anal fin that we see. You can even see somewhat of the structures at the head, at the anterior region of this fish. This fish did not die and float around on the surface or land on the bottom and just lay there doing nothing over a long period of time till slowly sediment was falling down upon the fish until it totally covered it. Because there's worms and stuff that live in the sediment too. doesn't do that. Isn't it interesting? How did this fish die? How did it do this? The fish is dead. It obviously was laying on the bottom. And how did its remains remain so absolutely perfect? Doesn't this fish look like it died quickly? This fish was covered by wet sediment, no question about it. This is limestone that you see all around the edge of the fish. This was the silty stuff that was falling. There's no question about it. I understand why Oxford University and college and high school textbooks and even elementary textbooks would talk about wet sediment falling and covering this fish. But you can see here, this is rock, but you have an entirely intact fish. It appears to me that this fish died very quickly and was buried in wet sediment. Death had to occur very fast for it to make a fossil. If it sat there for a period of time, it wouldn't make a fossil. Scavengers and stuff would have taken it. Look at this next example of a picture we have of a fish eating another fish that's found in a fossil. This photograph of a fossilized fish shows that it was in the process of eating another fish when it was instantly killed and buried by wet sediment. Now, this supports the Bible and the biblical account of what we normally call Noah's flood, in which the world was quickly destroyed by the floods and the organisms were then buried in wet sediment instantly. Before they could be scavenged, before they could be decomposed totally, they are intact. We see this. Or look at this beautiful example of a shrimp. The shrimp inside this limestone, you can see this is a nice thick block of limestone, but you can see beautifully how this shrimp is preserved. Now, shrimp are used as bait by fishermen all over the world. Thus, they're a very popular choice for food for many aquatic animals. And we find thousands of shrimp fossils all over the world. So my question is, how did this shrimp die? How did it get covered so quickly, obviously by wet sediment? I mean, Oxford's got that right. It had to be covered by wet sediment. Don't get me wrong, I'm not saying Oxford University is wrong. I'm just saying their time frame is a little off because this animal died very, very quickly. Now, how do we know that it died quickly? Well, for one, scavengers like to eat shrimp. You want to feed fish? Just go out to any dock or whatever, take some dead shrimp or whatever, or even live ones a lot of times. Just throw them out there. Fish will just gobble them up. It's sort of like taking somebody like myself to Red Lobster. You put shrimp in front of me, I'm going to eat the thing. And so there's shrimp being eaten everywhere. So shrimp is a primary food. But what a lot of people don't realize, the largest organ that you find inside of a crustacean, like a lobster or a shrimp, is called the hepatopancreas. Now, this is the largest digestive organ in the animal. What it does is has enzymes that break down the organism just as simply as we do too. When we eat shrimp, we have enzymes that break it down into food, and then our body can use these. Well, in crustaceans, now this is really interesting with crustaceans. When crustaceans die, the hepatopancreas, right upon the moment of death, starts secreting digestive enzymes. When the animal dies, it just does not go into the gut of the animal. It also goes into all the muscle tissue around. Thus, crustaceans, how would we say, they spoil, they rot very quickly. So once you kill a crustacean, instantly these enzymes start infiltrating into the meat, the part that we like to eat, and it starts infiltrating. That's why some cooks and chefs will take a live lobster and drop it into a pot of boiling water to kill it instantly so that the hepatopancreas does not secrete digestive enzymes into the flesh of the animal, and which starts to break it down and causes it to rot. And that's one reason why God told the Israelites, you don't eat these things, because they did not have refrigeration. They didn't have freezers and stuff. So shrimp, crustaceans and stuff, are actually an unclean food. Why? Very simply, because if the Israelites, like during the Old Testament days, went out and caught shrimp, by the time they got them home, they're already rotting. They're already starting to break down. And these digestive enzymes are getting all through the food, and the food is starting to spoil. God knew this because he created all things, and he said, hey, you don't eat these creatures because this is a bad thing for you guys to eat them. So he said, no, don't eat that. That's why People can sometimes get sick also from shellfish if it's not been prepared or frozen immediately, and it has to be instantaneous freezing to keep these guys from having their flesh rot. The point is, this shrimp that we have on this table here, this shrimp, and tens of thousands like it, are found in fossil form all over the planet, showing that they weren't scavenged. They weren't broken down and eaten by a lot of things. And there's a lot of things, even though it's rotting on the bottom, there's a lot of fish that'll come over and eat them anyway. That's why those of you who have fished, like particularly out in the ocean with shrimp, you don't worry about the shrimp being dead and stuff like that, because you're not consuming it, and fish don't care. They'll just break it down anyway. But that's another thing about why you find fossils like this shrimp here. They were killed instantly and buried in wet sediment all over the planet. That again shows evidence to fit with the Bible and what we call Noah's flood. It supports all this, that God destroyed the world because of the man had become so sinful that he destroyed it. The flood came quickly, and most organisms were buried and in this wet sediment, and when they were buried in the wet sediment, no scavengers, no decomposers, things like that could get to them. But I got to take you to the last one here that is the most interesting of all. I am holding a rock. Isn't that fascinating? It's a rock. Doesn't look like much. This was found over near Braidwood, Illinois, which is right where I used to teach back in the 1990s. And beautiful little round rock. When the rock, I mean, it just looks like it's just a piece of sedimentary rock. Looks like an ordinary piece of rock. Once we break this open, you're going to see there is an animal that was embedded in this rock. And as this has been already split, and I pull it apart and let you see the insides of this, you're going to see, if you look carefully, and I have to put my glasses on to see this because I'm looking too, there is a round section inside of this specimen here, and this one here also. You can see a round side. So there was something in here, an animal, it is an animal, that was found inside this thing. Now, as we look at this round section here, this is round. It's sort of domed a little bit compared to the edges. What we are looking at is a fossilized jellyfish. Yes, a fossilized jellyfish. Now this has got to be the most bizarre thing. And I'm so happy to have found this. And you can buy these online and stuff like this. These things are amazing to look at. A fossilized jellyfish. Now for those of you who do not know, let me give you a little marine biology structure on jellyfish. Jellyfish only have two cell layers. An outside cell layer called the epidermis, the external epidermis. Then they have one on the inside of their body, which is called the gastrodermis, the internal gastrodermis. Now, in between these two layers of cells is basically just a jelly-like liquid we call mesoglia. In that mesoglia, there's a lot of water. There's some proteins, and there's also some cells floating around in between these two layers. Do you understand what I'm saying? Jellyfish are basically just two layers thick with a bunch of water in between. They're like bags of water. Matter of fact, a jellyfish is 95% just water. There's not much to the animal itself. That's what we're talking about here. And here we have a fossilized one. So this is a fossil of something that is mostly just water. How do you fossilize water? It's amazing. Obviously, we're just not the fossilized water. We have two layers here. But the thing is, it formed a fossil. How thin is this that it formed a fossil? And also, how quickly this thing had to die and get buried in wet sediment to form this without being eaten by other things. Yes, a lot of animals do eat and consume. Crabs will eat, many crabs will eat jellyfish. Other fish will eat jellyfish. There are turtles that eat jellyfish and a host of other things that eat jellyfish. But this one here, this jellyfish formed into an absolutely fascinating fossil. Now, we see the dome, or what we call the bell, but I want to point out to you, you can make out the tentacles of this fossil. As we look, here I'm pointing to the bell with my pencil. You'll see a waviness, lines, rays like going out from this. that are embedded and made into a fossil. These go all the way around. Here they are really distinct. They're hard to find because remember, this is only a couple of cells thick. It was just water basically in between, this mesoglia. But here we see lines, forming these lines. Oh, here you can see some beautifully. These rays going out here, along here. Those are the small tentacles of the jellyfish. Now, what is this telling us? An animal that is mostly 95% water, only 5% cells, still became fossilized. It had to have been buried very, very quickly for this to form. Be buried in wet sediment that nothing could eat it, that the sun couldn't dry it out or anything like that. It had to form very quickly. This, again, I believe, is strong evidence pointing to a global worldwide flood, which fits the biblical account that we call Noah's flood. That Noah's flood churned up everything into the oceans, and schools of jellyfish, and by the way, they have found in the area around near Braidwood, Coal City, etc., in Illinois, there are just hundreds, probably even thousands of jellyfish, schools of them, that were buried all instantly and made into these fossils. So to me, this is great evidence pointing that fossils don't take millions of years. This happened. The fossilization occurred very quickly. It couldn't have taken a long time because the animal would have broken down and been destroyed and been consumed or things like this and disappear quickly with time. So the thing about fossils, it shouldn't make you not trust the Bible. Fossils should not make you think that Christianity is not true or the Bible's not true. As a matter of fact, if you look at it as the way I've just pointed out, it makes extremely logical sense that these animals died very quickly, were buried quickly, and that the fossilization process does not take millions of years. This shows evidence that Noah's flood took place. And we find fossils like these on every continent on the planet. Well, I want to thank you so much for joining us as we wrap this up today, and I hope that you've learned something more. Go out and look at fossils. Go to museums and stuff and look at them, but be wary. When they say that they're so old, they're probably not accurate. Besides, who was there to watch all this? And it doesn't make sense that you find these all over the world. This makes perfect sense. There was a worldwide flood, and that Noah's flood in the Bible, as recorded, actually happened. So, until we meet again, take care, and may God bless.
Support the show. Become a donor at evidenceforfaith.org/give.